An Ethernet switch is an electronic device that resembles a hub. A switch provides multiple ports that can attach to a single computer and the switch allows computers to send frames to one another. Some of the difference between hub and switch are that a hub operates as an analog device that forwards signals among computers, while the switch is a digital device that forwards packets. A hub simulates a shared transmission medium, while a switch simulates a bridged network that has one computer per LAN segment. The figure illustrates the conceptual use of a bridge and a switch. So an Ethernet switch, sometimes called a layer 2 switch, is an electronic device that somewhat resembles a hub. A switch provides multiple ports that attach to a single computer, and a switch allows computers to send frames to one another. Where a hub forwards signals among computers, a switch forwards packets. A switch does the combined work of a hub and a bridge. A switch does not contain separate bridges. Instead, consists of an intelligent interface attached to each port and a central fabric that provides simultaneous transfers. The interface contains a processor, memory, and other hardware needed to accept a packet and then consult a forwarding table and then send the packet across the fabric to the correct output port. Also, because an interface has a memory, it can buffer arriving packets when an output port is busy. The figure illustrates this architecture. Physically, switches are available in many sizes. In other words, they can contain a number of ports. An advantage of using a switched LAN instead of a hub is parallelism. The hub can only support one transmission at a time, while a switch permits multiple transfers to occur at the same time, provided the transfers are independent. Because it handles packets instead of signals and uses a fabric to provide parallel internal paths, a switch with n ports can transfer up to n divided by 2 packets simultaneously. Virtual Local Area Network, VLAN switches. Virtual means that it is created in software. The concept is straightforward. It allows a manager to configure a single switch to emulate multiple independent switches. A manager can specify a set of ports on the switch and designates them to be on virtual LAN 1 and designates another set of ports to be on virtual LAN 2, and so on. When a computer on virtual LAN 2 broadcasts a packet, only those computers on the same virtual LAN 2, will receive a copy of that packet. Once configured, a VLAN switch makes it appear that there are multiple smaller switches on the networks. A LAN is a local area network, and it is defined as all devices in the same broadcast domain. Routers stop broadcasts, switches just forward them. A VLAN is a virtual LAN. In technical terms, a VLAN is a broadcast domain created by switches. Normally, it is a router creating that broadcast domain. With VLANs, a switch can create a broadcast domain. This works by placing some switch ports in a VLAN other than one, the default VLAN. All ports in a single VLAN are in a single broadcast domain. Because switches can talk to each other, some ports on switch A can be in VLAN 10, and other ports on switch B can be in VLAN 10. Broadcast between these devices will not be seen on any other port in any other VLAN other than 10. However, these devices can all communicate because they are on the same VLAN. Without additional configuration, they would not be able to communicate with any other devices not in their VLAN. Dividing computers into separate broadcast domains may not appear important until you consider a large company or service provider. In either case, it may be important to guarantee that a set of computers can communicate without others receiving your packets and without receiving packets from outside your network. For example, A company may choose to provide a firewall between computers in the CEO's office and other computers in the company. Configuring a separate VLAN for the CEO's computer allows a firewall to be installed that excludes unnecessary activity between the CEO's office and other devices in the network. Switches are typically placed in physical proximity to computers, such as placing a switch on the floor of each building. This is done because locating a switch near a set of computers reduces the number of wires that must be run. VLANs that run across multiple switches require additional support, and each VLAN assigned a unique number. Packet control is accomplished by using an extra field added to the header of each Ethernet frame, known as a VLAN tag. When a computer broadcasts a frame, the switch to which the computer is attached delivers a copy to each local port that is part of the VLAN. It inserts the VLAN tag and sends the result across the Internet switch link. The second switch receives the frame, extracts the VLAN number, and delivers a copy to each computer that is part of the VLAN. The extra field in the frame, known as the VLAN tag, is a 16-bit integer that identifies the VLAN to which the sending computer has been assigned. This is only used internally on a network. 802.1q standard allows multiple VLAN switches to be interconnected and to operate like a giant VLAN switch. Per VLAN spanning tree, PVST plus spanning tree protocol, runs separately on each VLAN, thus can have different root bridges for each VLAN. Bridging is a fundamental concept that has been incorporated into many devices. An example is a DSL or cable modem that provides a form of bridging. The modem provides an Ethernet connection at the subscriber's residence and transfers Ethernet packets between the subscriber's location and the provider's network. Some wireless technologies also use a form of bridging to transfer frames from a mobile device to a provider's network. Although vendors no longer sell standalone bridge devices, the concept of bridging has been incorporated in network devices, such as in modems and wireless routers.